welcome to an AmbaSat Basics video. Today we wanted to cover some techniques for soldering PCBs, as even those with some soldering experience may not have done any SMD soldering before. PCB meaning printed circuit board and SMD meaning surface mounted devices. Let's take a quick look at the tools needed. A soldering iron or station is required. A multimeter is recommended for fault finding. A pair of cutters, the finer the better. Tweezers for tweezing. A craft knife is usually handy. And some extra toys and gizmos for desoldering. But before we get started, let's fly through some health and safety do's and don'ts. Do be sure to keep in mind that your soldering iron is hot. Don't be using it to keep your tea warm, however. Do make sure your workspace is well ventilated, either with extraction fans or at least be sure to have a window open for airflow. Don't hotbox yourself in a confined workspace with no airflow. And finally, do be aware of your cable management. It's far too easy to accidentally melt through any power cables. Don't leave your iron placed on the work surface. Cage it and power off when not in use. With that out of the way, let's prep our workstations. Wet your sponges or get your head cleaner to hand. Warm up your soldering iron. Depending on the solder you're using, you may need a higher heat than seen here. But before we start, here's a little trade secret. BlueTack, our unofficial sponsor that didn't actually sponsor this video. BlueTack is the perfect helper when it comes to soldering. Take note in the coming exercises how it's used to make life just that little bit easier. For the following exercises, I will be using bare PCBs and a few components from an AmbaSat engineering kit. The first exercise I will be demonstrating today to help practice your steady hand and patience is to solder an SMD resistor to a PCB. You might not recognize these little guys compared to their through-hole resistor cousins, which you may be more familiar with. Unlike through-holes, which have limbs that are pushed through holes and then soldered into place, SMD resistors mount between two contacts. So, locate where you'd like to solder your resistor to the board. I will be soldering points marked R3 and R4. Start by heating up the contact with your soldering iron for a second. Feed a little bit of solder onto one of the contacts. Hold the iron there for a second, then lift. Now, taking care of your tweezers. Don't squeeze too hard, otherwise you will be chasing your resistor. Nudge the resistor towards your soldered contact, reflow the contact, and nudge the resistor into place. If needed, commence an internalized struggle with your OCD until components start lining up with the contact pads like they're supposed to. That's better. Now just apply a little bit of extra heat and solder to the opposing side. Feel free to repeat this exercise as many times as is needed to get more comfortable with SMD. The next exercise will demonstrate flush and conical soldering. When mounting a daughter board to a PCB, like our solar board for example, conical soldering can sometimes cause clearance issues. I'll show you how to avoid this using the spare daughter board. I recommend using a little bit of M3 tape or double-sided tape just to help keep things in place. Not much is needed, just a small square on the rear of the daughter board will do. As I line up the daughter board with the I2C interface on the main board. I2C standing for Inter-Integrated Circuit. A quick callback to our unofficial sponsor for this video, being BlueTack. BlueTack can be used in a few configurations when it comes to soldering. This next configuration I like to call the high-tech sausage. Please, I can't believe I have to say this, but please don't eat the sausage. This is then placed over the contacts as seen here, then turned to expose the rear, where on this particular board a flush solder is desirable. Take care not to compress the sausage too much and insert connection pins like so. Because I'm after a flush solder, I am cutting the pins as close to the board as possible. Once cut, notice how I take my tweezers and tap any protruding metal further into the blue tack, just to embed slightly. Onward to the soldering itself. Keep your tips clean, let's do this. When aiming to keep things flush, less is more. You can always add more solder later. And similar to before, we want to heat the contact pad first with our iron. Hold it there for a second and introduce the solder. But rather than lift, we just want to glide the iron away, leaving a smooth, almost flush solder. Don't worry about it not coming out perfect, because we can tidy these solders up once we have soldered the top side of the daughter board. Notice how I keep my iron present even after I remove the solder, almost as if to allow the solder to temper or cure. Ooh, that's a nice solder. You can often get a flush solder like this, but since we're going to be soldering the top side of the daughter board, more solder will trickle through and potentially ruin our flush solder. As I said, we can tidy this up after the top side has been done. Now for the top side, turn your PCB back over, remove the blue tack and any lingering residue of blue tack. Now with the top side, a flush solder isn't really needed, so a conical solder would do just fine. You're probably more familiar with conical soldering than flush soldering, conical soldering being those domed or tipped solders you see in most electronics. So because we don't need a flush solder, just cut the pins down roughly. Utilizing yet again our handy blue tack, make a small ball, place it on the rear of the PCB, and this will just help stop the PCB from sliding about while you are working on it. Make contact with the iron and the pad and the protruding limb for a moment before feeding in solder, holding the iron and then lifting away to form a conical solder. Now usually if a bit of extra solder trickles through to the rear and ruins our flush solder, you can turn the PCB and just run the iron over it to allow it to reflow and run smooth once again. But to be safe, I wanted to cover some basic desoldering techniques to help cases of excessive solder. Now there's a few techniques when it comes to desoldering, but I'm going to stick to the basics using a sucker gizmo and copper wick. The gizmo utilizes a spring-loaded mechanism where upon release creates a vacuum, which is quite useful when it comes to shorts like this. Simply reflow and boom, gone. Just be careful not to lose your components in the process. But say you get a bridge or a bulge where you want a nice neat finish, or you have excessive amounts of solder on component leads. This is where copper wick may be more applicable. Copper wick is literally a wick of copper which has been infused with flux. Flux being a chemical compound which helps liquefy your solder and seals out any air, preventing any oxidization further down the line. Use by simply placing the wick over the affected area and applying heat using the iron. The solder will reflow, but take care to keep the wick moving once the solder starts to reflow. This is just to help to prevent the wick from sticking to the contacts. Once you have completed your soldering, inspect each solder you have done, perform any necessary cleanups and tidy ups using your iron just to neaten things up before spraying down with alcohol, as this will help you wipe away any flux residue which has built up. And that's it for our AmbaSat Basics on soldering. Would you like to know more advanced techniques for soldering? Could you have basically done this better? Let us know in the comments section below. Thank you for watching, and find out more about AmbaSat at our website ambasat.com.